Hi, everyone, and welcome to our December webinar. Today, we have a lot of stuff packed for you, and we could see you can see that the dressing is also on point. So hopefully, it's going to be a fun session. We will have a lot of topics for today. We're going to cover a lot of stuff that happened in the cloud native and Kubernetes world. We're going to start with Edge, WASM, GitOps operators, and more. I'm not going to list everything here to keep some surprise as well. So a bit of housekeeping for today. So as we go, you can ask any question you want in the chat. We'll make sure to respond to all of them, or maybe at the end if you want to also keep your questions for the end. One thing to notice is that this webinar will be also available on demand. So you can watch it afterwards if you want, or share it with your colleagues. Also, on some very specific slides, we will have polling questions for you guys to answer. And if we have time at the end, or if we see that you guys don't agree with us, and we'll take a look at them and maybe comment.
It's very possible.
We'll see about that. So with that said, let's get stuck in. So maybe we start with the intros. So let's remove my glasses so you guys can see me. Do we see the slides, by the way? I don't see the slides.
Yeah, Junkie, maybe it's on auto. It's on auto.
And you should share the screen, I think.
Yeah, that might be a good idea. Always these technical difficulties.
That's fine. I'm going to introduce myself in the meantime. So my name is Nick. I'm leading the DevRel teams here at Spectro Cloud. I've spent about the last 7 years looking after Kubernetes-related technologies, CNI, CSI, engineering, product management, tech marketing. I've done pretty much everything. If you want to find me on the internet, I'm on Twitter or X, should I say. You can also, add me to your LinkedIn contacts. I'll be more than happy to help you for anything you want. And today I'm joined with Anton.
Yeah, that's me. So I don't have as much time with Kubernetes as Nick, but I do have a lot of time with networking. I'm Director of Product Management at Spectro Cloud. I've done the last 3 years with Kubernetes and open source technologies. I've spent some time at Canonical, where I was product manager for MAS, Middle as a Service. I've spent a lot of time in the networking world building ISPs or at telco vendors like Ericsson, Nokia. I'm not a metalhead. I'm an alternative metalhead. And if you want to find me, I'm Anton Smith with a 5, or you can find me on LinkedIn, where I'm normally posting lots of inane comments, but usually trying with some interesting stuff. Okay, so that's us. And the first topic that we want to talk about is Edge, because it's very near and dear to our hearts. And it's been a very eventful year. So let's talk first about what's happened in 2023. Now, Nick, you were asking me, why did I put this crazy number, like this picture?
Yeah, why 93?
Why did I put this here? What is this 93? Burning chips and stuff. Well, first of all, it's a DALI image because we like playing with AI. But this is a very important number because we had a survey run by Spectro Cloud where we found 93% of our participants said that they are planning to use Kubernetes for edge computing.
I thought that was your years of, birth.
Yeah. Did the presentation just go away, or is it just swapped over?
Yeah, it just moved away.
Okay. I think I'm going to fix that because it shouldn't be doing that.
Yeah, I thought 93. This is the year you were born, but you don't look that young, do you?
I wish I was, yeah. So I'm also trying to stop it from doing this swapping around.
So 93 is still is very high. I wouldn't expect like 93% of people using Kubernetes for edge computing.
No, but I think that the edge computing has been happening for a long time as well. Let's also remember that we've got routers are basically edge computing, the ones you have at your home or the ones at enterprises. But there's something new here with Kubernetes. It's been enabled by a new driver, which is about the disaggregation of the hardware from the software or the application. What that means is that now you can go and buy any type of hardware off the shelf, like these small, industrial PCs or x86 boxes, and you can go and load some other router software. You don't have to buy it from like any particular vendor. And of course, this completely unlocks things for stuff like Kubernetes, because now there's a bunch of applications that you want to run and you want to run them at the edge. You can do it on any commodity type of hardware. So that's a very important driver, disaggregation. The other thing is that latency and workload placement. So we want to bring the workloads closer to the edge or closer to where the things are going on. So for example, cameras is a very easy one to explain. You don't want to run all this, you don't want to pipe all that data back to a central location when all you want to do is recognize if there's a person in your front, at your front door. You can recognize that easily at the edge instead and avoid sending all that data back somewhere else. Of course, there's also many more use cases with much more data processing. A lot of it is being driven by machine learning or AI applications, and also decentralization. And last but not least, as a driver, is cost optimization. So edge is about also trying to cut your costs on maybe expensive cloud compute. You can place the workloads and process them out there with your own silicon that you own, and you don't really have to pay for the transport of the data, the storage of the data centrally, and so forth. So really, people are looking for flexibility. They have the ability now with disaggregation, and there's this cost optimization. And of course, the other thing is that Kubernetes and cloud technologies have become preferred by people. They know how to use them, they want to use them, and now they want to use it at the edge as well. And so we believe that Kubernetes is the technology to use at the edge for anybody who wants to push their applications to more locations. And then on challenges, there are many challenges with running Kubernetes at the edge, in particular monitoring and maintenance. There's how do you manage all of these clusters at scale? You're not talking about like 5 large clusters that you're running centrally. Now you may be talking about hundreds or thousands of small clusters located everywhere in all different kinds of environments. Maybe they had poor networking or even no internet at all, and a whole host of other issues. So that's something that I think that the industry is coming to grips with. And if we look at 2024, then I think that will be this awakening of edge, and the desire to have edge Kubernetes is going to push a lot of adaptations continuing into 2024. So first of all, almost every industry is interested in edge Kubernetes. Anything from 5G telco use cases, augmented reality, autonomous vehicles, so transportation, ships, manufacturing, public sector and government, defense, smart cities. It's pretty much across the board. Now, the other thing we expect to see is that there will be adaptations for edge. Kubernetes was not actually designed with edge in mind in the beginning. So there will be some adaptations being made. For example, people might want to have just 2 nodes at the edge to have high availability instead of 3. They might want to bring in etcd shims, so they use Kine, which is a technology to allow you to switch out the database in the back end of Kubernetes. Maybe you want something more lightweight. Storage technologies like Longhorn might come in here.
Yeah, so do not mistake Kine, K-I-N-E, not kind, which is another technology.
Correct.
Right?
Yes, exactly.
We're not talking about kind.
That's a good one. Kubernetes and Docker, that one. Yeah. Another thing that we're expecting to see is the more AI-driven operations. So not just the deployment of AI workloads at the edge, but AI being used to help you monitor your clusters at the edge. And especially, as I mentioned before, if you have thousands of clusters, well, this is going to become a problem. That's a lot of logs that you need to look at. And you see projects like Kate's GPT from Alex Jones, who's now at Amazon, I believe. These are amazing technology, and even these can run locally with local AI. Local AI is a project that you can Google, and you will find it very quickly. And then, of course, we think there will be more hardware choice. So we've had a lot of x86 boxes, but now there's a lot more ARM coming in. Very important technologies like Jetson. If you have seen NVIDIA Jetson, it's really cool. It's like multiple ARM cores with built-in GPU, and just perfect for edge AI. And then of course there's one here that I think is very important, which is build versus buy. Most of the Kubernetes clusters out there today, I believe, are home built at the edge. So it started a lot with retailers, and retailers have been building their own setup, etc. But now I believe that people might be starting to understand that this is not their core business to build these solutions. So I think that the build versus buy discussion is going to become far more important in 2024.
Yeah,
and certainly there's more choice.
Yeah, I also think standardization and repeatability, because of the scale of edge, become very important. In terms of operation, usually you don't have like skilled people at the edge. So whether it's build or buy, I think the key thing about edge is immutability as well, right? You don't want to operate snowflakes. You want to operate something that is similar regardless of your location. And I just want to shout out to our open source project, which is Kairos, which is our Spectro Cloud Edge solution is based out of that project, which allows you to build bespoke Kubernetes, K3s distros with immutable partitions. Like the one you want to make immutable can be immutable, and the rest can be, of course, you can have like data that pertain across different reboots. But the key thing that is really there is that in terms of the updates, the upgrade, the maintenance, the operations, it's like upgrading your iPhone, right? You just replace the system entirely, right? And you have, of course, if it fails, you can boot to the previous version. But really here, the key is you don't want to treat your systems as a snowflake. I think moving forward is going to be even a more problematic approach for people because of the scale of the ML workloads, AI, all of that is going to continue to grow in 2024, I think.
No, totally. I think this is very interesting because as I opened up with, edge computing has been happening for a long time. Like even IoT, for example, it's edge computing. Oh, yeah. But what we're talking about now is specifically Kubernetes coming into the world of the edge. And
because and edge applications sometimes are delivered as cluster or as Kubernetes Helm charts by default, right? So this is the new form factor for most modern application just to deploy, right? This is how they are packaged. It's not a binary, it's a Kubernetes cluster, right?
Yeah, and certainly if you look at the ecosystem, the CNCF ecosystem, that's also a massive number of projects there that are mostly packaged and designed to work with Kubernetes. So if you want to get access to all of that and use it at the edge, then Kubernetes is the way to get that.
Yeah, I think we're good for edge. We've been burning already like too much time on that, but yeah, it's such a interesting topic. Hopefully, and if you guys have questions, don't hesitate to ask them as well.
Yeah. So WASM, Nick, what is it? And can you tell us what it's going to look like in 2024? I'm sure this has been a hot tech, but let's hear about it.
Yeah, sure. So, the way I see it, it's a good transition from edge because WASM is coming to Kubernetes. So first, what is WASM? So the way I like to see WASM is it's not like technically super like 100% accurate, but it's like what was servlet to Java, right? Is WASM to web browser. So it allows you to run super fast application, a binary, bytecode directly into your browser, like over HTTP2, HTTP3, all of that. But now, WASM has been there for some time. It's still like, improving technology. It's not been there for so long. But what is special now in terms of Kubernetes is that you can run WASM binary directly into Kubernetes, not as container, but you can make containerd aware that you're actually running a WASM binary and not a container. So what that means is that you can have your container running alongside WASM binary. So, and then why WASM? Because of course it's considered like, a Java JVM. It's a sandbox environment. It's portable. There is low overhead. And also it's polyglot, meaning that you can have any existing program in C, Go, Java maybe, yeah, probably Java, Python, whatever, and you can compile them into WASM, like low-level WASM, so WebAssembly language that will run in Kubernetes via containerd and WASM Edge, or directly into your browser. So this is why it's kind of a revolution now. It's because this low overhead, as well as the portability, like container were really portable. It's like now, okay, we have binary running inside container. Now we can have binary scheduled directly by Kubernetes without the container layer, right? Not OCI compliant, I would say at the moment.
One thing, Nick, I think that's very interesting with that is that, containers, they are portable, but you still have to have different ones for different architectures, like ARM or x86, right?
True.
So for WASM now, it's more like people will just write their applications in whatever language they want, C or C++ or whatever it is, and then they create this WASM, what is it called? A WASM thing, a bundle,
binary.
And a binary, and it can run anywhere in your browser or on an ARM box or in a server.
And I think you were quite fond of the project that allows you to run the whole operating system in a browser.
Yeah. I mean, just incredible seeing an operating system running in your browser. I mean, I never would have imagined it. So let's go on to what's going to happen next with WASM just quickly, so we can get on to the other topics.
Yeah, sure. So I mean, in terms of where we expect other application of WASM within the cloud native ecosystem, of course, for serverless platform, because it has a faster call start time. So which means that if you scale to 0 and then to 1 or 10 or 100, it's a lot faster. And as I said earlier, it can also run alongside containers. So you don't have to dedicate another platform just by implementing WASM Edge as this intermediate layer between containerd and the binary. Of course, edge computing, same reasons, extra security, sandbox, all of that, ticks all the box for an ideal integration with edge computing for fast data processing. And in terms of the form factor, I think in terms of scale, you will be able to stack.
They're very lightweight, right? They're very small.
Yes, super lightweight. So you will stack more binaries than containers, for example. It has even less overhead. And of course, we have started to see a couple of projects within the CNCF landscape. So we are expecting it to grow. For me, it's still the very beginning. There's also, in terms of the community is growing at a fast pace as well. And every, community event now always has a couple of talk on WASM. And I'm really fascinated by WASM, statically compiled. You don't need any dynamic library, fast, secure. So at the moment, it's ticking all the box. And to be honest, I was waiting for so long that something can maybe finally replace Java.
But our prediction, I think we're both on the same page here, right? We're going to see this thing keep growing, and the amount of investment in projects around it, especially making it better and easier to use in Kubernetes, is just going to continue. By the way, I think that says as much about Kubernetes as it does about WASM, because Kubernetes is so flexible, and because of all the open source componentry, it's like, yeah, why not? Let's have another way of running stuff.
Yeah. I think we're going to mention it later, but Kubernetes has really become like a platform to build platform. It's a Lego block, right? So yeah.
Okay, Nick. All right, now this one.
Okay. So I see GitOps everywhere. This is, like a couple of years ago, like 4 or 5 years ago, I thought, yeah, it's just a fad. People are just talking about GitOps. And I was very opinionated about GitOps. Like when people were just, and I still am, because where it's coming from, I tend to associate GitOps. Like if you put something on a Git repo for infrastructure and you just share it and do PR to modify your environment, for me, it's not GitOps. Like where I see really GitOps fits is with a Kubernetes controller, right? So GitOps is this idea of having everything, all the configuration as data or as code sitting in your GitOps repo, but then you also needed a process to apply that configuration. And most of the time it will be done, where it's coming from, done via, Flux or Argo CD controller. And those two projects are still ruling, the GitOps world. And I think also that, deploying software in Kubernetes remains an area of focus for developer adoption. So, GitOps is also a vector for developer to adopt Kubernetes, in the sense that, of course, you have the DevOps workflow, the DevOps admins, the DevOps engineers that facilitate the process, so that developers who are developing an application on Kubernetes then can only focus on developing the code, and then throw that into the GitOps process, and then automatically it gets into the cluster. So I think there are still challenges in terms of GitOps. As we know, we're going to talk just after that, there are more and more things that you are running in your Kubernetes cluster in terms of customization. There's a bunch of software that can modify the reality or the truth, the single truth that is sitting within your GitOps repo. And then if something modifies this configuration into the cluster, then you may have a challenge, because the GitOps process will revert it back.
So this is basically you're talking about mutating webhooks, right? You brought that up with me the other day, and I myself have certainly run into being confused trying to trace the chain of all these mutating webhooks. Now, those are just basically taking some actions after you are trying to access the API for Kubernetes, and they're altering what you're trying to do. So now you have your single source of truth in your repo, your GitHub repo, and then you think you're pushing something down, but then it just gets magically changed by something else that you've set up. And so this becomes, tracing all of this and reconciling this and understanding that what you got and what you ordered look different, but actually there was this kind of thing in the middle changing it.
So there are a couple of things you can do for that. So of course you can have exceptions, right? So you can flag special, like object properties or properties you have to be ignored by your GitOps process, which is probably what you should do anyway. But also, where GitOps is going into is this kind of shift left principles, like making the platform for engineering and developer a lot easier. And there are a lot of tools that combine GitOps with developer tools. So in the past we had Docker Compose, or just running Docker containers. Now we have a lot of, for developers, we have a lot of better tools like DevSpace, Scaffold, Dagger. All of them, they have this sort of GitOps properties and ability to create GitOps pipelines. But at the same time, this is where you build your images. This is where you can also create dev containers and troubleshoot remotely those containers with Delve and other developer-specific tools. So now we are already in this situation where we have those pipelines that are kind of bridging, development and infrastructure, but more and more shifting left into the developers' world. Why? Is for them to go faster, have those agile, faster cycles.
Yeah. So we need to move on, but I just want to add before we do that we're also seeing GitOps. I'm seeing a lot with our customers and in the industry in general, infrastructure as code with GitOps. So for example, going back to Edge, you want to have a new Edge cluster out there. Well, when you take the boxes out there and you plug them in order to do the plug and play and figure out who they are and get their identity, we're actually triggering GitOps pipelines running somewhere else and utilizing information from the site, like some tags or some identifier about the network. So it's all pipelined. And so that's actually really cool to see that kind of thing, just triggering off a box being plugged in, which of course the benefit to that is making it very easy to monitor it and keep track of what's happening. Some people are creating a repo for every site that they're managing and deploying. Anyway, let's go on. Operators and custom controllers. I'm very interested in this one. And just as a quick intro, Kubernetes is basically built off controllers. And what controllers are doing is essentially sitting there and looking for the presence of some instructions or some information, and then running some kind of logic and then spitting out some other type of information. So if you imagine all these people running around, you can imagine it's almost like a business when there's a process of things that happen and people are all running some kind of process in their head and then controlling the inputs and the outputs. Now, Kubernetes is extensible. And so even though Kubernetes itself comes with a bunch of controllers, which is how it all hangs together, now people are creating controllers like crazy. And this is cool and challenging. And Nick, maybe you want to say something quickly about what you're seeing with the controller landscape.
Yeah, sure. I mean, everything now is an operator. It's the way to install application, but I think it's required, especially for stateful application, with this notion of, okay, we've got the platform. How about the application? Like I'm going to spin up 3 containers. Those containers must run a database cluster. How do you make sure that you can encapsulate the required knowledge to create this database into Kubernetes and use Kubernetes itself to drive automation? So, and I love this approach of using Kubernetes not only to run application, but to use Kubernetes as the de facto data center or cloud automation engine. So now we have this combined world where you run application and the automation of the application and the infrastructure, everything on the same platform, right? Because of course, Kubernetes is super extensible, which means that you can make anything you want first-class citizen into Kubernetes, like database, I don't know, like a cup of tea if you want.
Yeah, like you are extending Kubernetes. Anyone can extend Kubernetes.
Exactly.
What I think is challenging about this, though, Nick, is like it's interesting because you can start to say that some people are blending their applications. They're building their applications by creating controllers for Kubernetes, and then it's like, where is the line? The line is getting blurry between where your business logic is. Is it in your code that's running inside the containers, or is it now somehow kind of spread between Kubernetes controllers that you wrote and your application?
Yeah, and I think it's both direction, right? Because now some of the part is coming into Kubernetes to do that automation. And for example, for observability, with things like distributed tracing, now this is something from the platform that has to go through your code. So it's like bi-directional. Application has to be adapted to Kubernetes, and Kubernetes need to be adapted to application in terms of some sort of automation.
I was listening to the Google Kubernetes podcast the other day, which is a great podcast for anyone who doesn't listen to it. And they were just having this conversation about all of these CRDs, which are these custom resource definitions that essentially are associated with all of these controllers. And it's becoming like, as many stars in the sky. That's how many different types of CRDs there are now. And this is why we put
it's like your personal subscriptions to like Netflix.
Your email subscription.
It can only grow in over time. It cannot be reduced. Netflix,
exactly.
Plus,
are you an inbox zero kind of guy? Because I have like 30,000 unread emails.
Yeah, but for me, like that's a good transition to security, because one of the main aspects of that, by adding more and more custom stuff into your cluster, is potentially creating security breaches, security hole. And as one of the survey that we have basically organized is sent to a lot of people adopting Kubernetes, is that you can see on this graph, security is still the key concern when adopting Kubernetes, even before performance, scalability, or even before cost, right? So
and don't forget at edge, because then you have a whole bunch of other things to think about, like physical security. I mean, access to the box, not like I would need a bodyguard to go and deploy my boxes, but it's like people can pick up the boxes and walk away with them, steal the hard drive, and maybe get access to all that sensitive data that's out there. So security is just like across the board.
And supply chain. I think this is the good transition as well.
Chain, exactly. So let's go on to that one.
You have a story to tell us about.
So supply chain attacks. Well, that's one thing, but actually the other thing here is still, like, regardless of technology, social engineering, hacking people instead of hacking the code. And that's why we have this move to zero trust principles. And there was this amazing, like, shocking story about this poor employee at Okta. All he did was log into into Chrome with his private account on his work laptop. That's all he did. He didn't do anything else. But because his private account, Google account, was compromised, they managed to get in there and basically, completely exposed some of the Okta information data. So, as always, we have to be very careful with people rather than processes or software. However, in the design of our systems now, this is why adoption of zero trust principles is just going to keep growing. It means never trust and always verify, and principle of least privilege. So that means very quickly, and I do not think that this is ubiquitous. In my experience, people talk about least privilege all the time, but they don't actually practice it. So in this case, if this guy only had access to the things that he should have access to, perhaps there would have been less loss of data or information than if he accidentally has too many permissions. So it's basically keeping the blast radius smaller by default.
And that's a couple of recommendations. If you go there's a bullet point here. If we relate this to Kubernetes, I would say, for everyone here who is either a platform engineer who's directly working with production or any environment, there's a couple of things that are really quick wins. Install a controller that can check for image signature. That's one. Create, a SBOM for all your code, your application, and store them, on Git. And
SBOM is the software bill of materials.
Yeah. So Sift and Gripe are two very easy tools you can use for that. Create the SBOM, and then you can scan with Sift. You can scan the SBOM with Gripe, and for it to be very efficient, then you should also, it's going to scan the image, right? Your container image. Use multi-build process with distroless images. So start the container from scratch if you can, which means potentially you have to disable some of your compiler option, but it's not really important. But the point is, remove these extra layers because it reduces the attack surface. As easy as that, right? And add all that into your pipeline. So it's also, we keep talking about shifting left. Shift security left into your pipeline. So you have this baseline. So even if you make mistakes into your production environment, it's still, less important or as impactful as if you started from scratch with no baseline, right? That's basically my point here.
Mm-hmm. Yeah, and I think that the single source of truth for your policy is about what you should have in your Kubernetes clusters. Like that's a very important thing as well. Not only scanning and seeing what's in there, like to check that they haven't deviated, but also seeing what is supposed to be in there so that you can compare. And then again, thinking at scale, you have to do this across 1,000 clusters. Everything basically has to be automated. There was something we added here too, Nick, that we should speak about, which is a validator tool that we're working on. This essentially can go and check. You can have a policy, you can define this with a very nice language, and then you can go and check your clusters with this validator tool or your cloud accounts. So for example, if you give a cloud account credential like your AWS or something, you can use this validator tool to go and check like, oh, what permissions should I have? Oh, do I have too many permissions? Maybe I don't have enough permissions. Whatever it is, that's up to you to be able to define and then check.
Yeah, I think this is quite needed because most of the time, whether you're using Spectro Cloud or any other solution to manage your Kubernetes fleet, you always expect some, prerequisites on the cloud, in a data center, in a VMware environment, or maybe it can be, checking things in Terraform, in Kubernetes, using Kubescape. So all that, at some point, we need a tool to bring all this together and chain them together so that, okay, now we clean. We have validated that everything is aligned with our policy guidelines, and then we can move forward. So yeah, this project is super, super interesting.
Yeah,
but yeah, and the tune is gonna.
Yeah, Nick, guess what? It's implemented as a controller.
Yeah, of course.
So you can run it in
what
your
else?
clusters. Exactly.
One more.
All right. Next
let's move on.
Oh no, there's one more thing here. In this security model, zero trust model, TPMs, trusted platform modules for hardware. Again, it applies to the cloud as well as to edge, but it's very important in edge. Yeah. Basically, only running the right software. because these boxes are out there. You can really meddle with them. So you can try to get them to boot something that is malicious because you have they're easier to get physical access to, and then you're able to start stealing data. So TPM, which is actually quite well supported by Kairos, the project we mentioned before, which is an open source project, TPM support coming in there. And I think that this is going to be like in 2024. It's absolutely critical. I think the old guard of edge devices, they have had more of this type of support. But now with the cloud, CNCF type of view coming into the edge, there's going to be a meeting of these two worlds where we really have to level up the game in the industry.
Yeah, if you listen to this also Kubernetes podcast where they were talking about TPM and HSM as well, hardware security module, better, higher capabilities in terms of what you can achieve there as well.
Exactly.
So yeah, I expect to see more innovation in that space.
So time check here, Nick. So we're at 31 minutes, and I think we need to pick up the pace just a bit. But this one is really interesting. The service mesh battle. I love this one. So, I don't know how closely you've been following it, but I see there's these two camps. There's the Istio camp and there's the Cilium camp. And they're doing it in different ways, which we are going to talk about in the next slides too. But what do you think?
It's funny. It's funny because I'm in DevRel, so my job is to do all those KCD events and all those community events. Every event, you will have one of each. You will have a lot of people from Isovalent and people from Solo, which obviously they pitch their friend story. So there's always both sides of the same coin. But ultimately, I think they all converge into, okay, we have to keep both options. Right? So that's the Istio view, both options. Cilium, we're going to talk about eBPF in a moment as well. Their business is eBPF. So, of course, do everything with eBPF and potentially solve the data plane issue by not having sidecar.
Yeah, exactly. And I think just because we need to move on, but quickly, we're seeing both. It depends on customers as well. I think both of these projects are amazing. They've both got great approaches, and listening to them talking about why they're doing things the way they do it, both sides have great points about what they're doing.
And just to mention here, I think that the architecture of service mesh is kind of moving away. So ambient mesh is more like a new sort of overlay and implementing everything layer 7 into an envoy proxy. Cilium is more like keeping the data plane eBPF, but keeping the control plane, separate and not using eBPF. And talking about eBPF here, of course, there are pros and cons. I don't think eBPF has a lot of disadvantages, but obviously we hear about it so much that it can be this, eBPF is a hammer, so every single issue looks like a nail, right? That's the typical.
And it's also it's also cool, right? It's got there's kind of like a hardcore cool thing going on there because it's all about performance and taking things down into the kernel level instead of.
If you look at the code, it doesn't look cool at all. It's super low level, right? So
it's super low level. So it's kind of it is. I just describe it as kind of hardcore, but no doubt that it definitely has applications in the industry
everywhere.
Cilium's using it and others are using it. But Nick, as you mentioned, it still has some limitations. It's maybe not always the best choice, depending on just how big the things are that you're trying to do in the kernel space.
Just a question here from the audience. So talking about Linkerd as a service mesh for in the service mesh space. So they changed it quite a bit. So definitely they are there as a good third choice. In terms of adoption, I don't see them. I don't, even in the community, when we are going into those events, the main conversation, they are revolving around ambient mesh and Cilium and eBPF service mesh as a data plane. Linkerd, it's coming a little bit into the conversation, but of course, it's a CNCF project, so it's going to be improving over time. A lot of people are going to continue to contribute to it. So there's going to be a lot of innovation in that space. So maybe Linkerd at some point will overtake the other ones. I would say now it's probably third position, but nothing is written. So it may happen.
I think with Istio changes, to with ambient, that that was a very necessary change that they're making there, and I think that helps secure their space where they are.
Yeah, but now, I'm always a bit. We have to see in practice, like in production, how it goes without a sidecar. It removes some issues, even though with sidecar now there's a new feature that allows the Kubernetes API to be aware of sidecars, so they are manageable in an easier way than before. So I think it's going to be a bit of both, right? And and also eBPF. The only thing I wanted to mention about it, some disadvantages, right? Because it does have a few drawbacks, especially around L7, and this is why you still need to keep Envoy. It's great. eBPF is great at processing packet flow because it's happening in kernel. If you have to do like a packet per packet analysis, then you will have a lot of overhead, a lot of complexity. So this is why this may be the only place where eBPF is not great. Like observability.
This is also because of like the amount of state you need to keep to be able to do that kind of thing.
Yeah.
Okay, so let's hit sustainability. We're almost there. Our marketing department said that there's no way we'd get through our slides, so let's see if we can do it. So sustainability. Yeah, but remember, this is sustainability from a nerd perspective. So we're talking.
Yeah, it's our way to contribute to the planet.
Okay.
So sustainability is in the CNCF landscape. There's a technology advisory group. Is that TAG? Yeah, stand for? I think so. Yeah, for sustainability. And the main deal here is how can we help Kubernetes behave in a better way when scheduling workloads. So it's a combination of multiple technologies. One is extending the current Kubernetes scheduler to make it aware of the current power, the current consumption, and needs for the application you are going to schedule on the cluster. That's one. And the second one was also a feature that appeared in 127, which is a way to change workload resources live without having to restart the pod, right? That's also, I think, a good thing. So that's the foundation.
That's exciting to do that.
How do we do that? Now we have to make carbon aware decision, right? And for this, there are a lot of science research at the moment to leverage a lot of data, like I've mentioned, platform-aware scheduling, telemetry-aware scheduling, which is a way to kind of bubble up, specific hardware metrics from the low-level, metering into Kubernetes, into this decision process. So we are also using ML AI model to work with this, as well as environmental data, such as where is the data center located, what's the temperature outside, all those kind of factors.
Power costs, and whether the power is being generated by coal or something. All of that kind of data can be used. So we're talking about these AI optimized data centers. There's a number of other capabilities apart from the Kubernetes side that I just want to mention, but like on bare metal, for example, if you're doing elastic scaling, horizontal scaling, maybe when you can scale down your cluster, you actually turn the machines off that are not hosting anything anymore. They're not just sitting there in low power mode. They're actually just off. And I think that's also extremely important.
Yeah, and that's just to add to this. So this is like quite advanced, the beginning, but there are a couple of things you can do today to save costs. For example, you can use operators, right? Like kubectl, another one that will help you, create cron rules to shut down pods that don't need any specific resources, like by using CRDs, all those kind of things. And also you can, in the cloud, right? You can use those ephemeral nodes. It's like spot instances as well, right?
Yeah, definitely. I think that's.
So those,
I'm also very curious about spot with actual hardware state. But what about next year?
Yeah, so basically for next year, it's, as I said, is the early days. So expansion of sustainability tag, development of best practices. So the tag is really there to bring us the technology as well as the guideline and the best practices, like they've been doing in the past for security, all those the different components. We're going to see more and more advanced carbon orchestration from the scheduler, so more and more projects coming in. I expect also some of the metrics I was mentioning being native into Kubernetes. I really hope that we have those projects coming in. And of course, it goes also, it's the responsibility of everyone in the community to make all companies aware of those projects for education, advocacy, hardware optimizations. And yeah, it just starts with us, as always, like in real life, not in the nerd life. It starts with us. So we have to educate people.
Yeah, no, just quickly about hardware, I think when you think about certain technologies, there's some interesting talks and stuff out there, but everything matters. 1% matters. If you have a CPU that is 1% more efficient than something else, and then you talk about the scale of hyperscalers, we're talking about, I don't even know how many tons of carbon that represents. Not talking about the manufacturing of those things, but it does matter. And so architecture matters as well. ARM versus x86. We're going to see, there was Graviton 4 from AWS the other day. Yeah, we are going to see more and more. My prediction, we're going to see a big wave of probably ARM and RISC-V coming into this space.
Yeah, I agree.
Okay, now we're on to our last one, which is the biggest debate, right? Platform engineering versus, or is it the new DevOps? Are they the same thing? Are they different? What's this all about? I love this topic. And, Nick, you found this like the hopes and dreams of DevOps, and platform engineering just comes along and takes over everything. But actually, it's not like that. DevOps is more, I think it's always been misunderstood. It's been like this panacea for everything. But actually, it's more like a mindset. It's like a cultural thing, whereas platform engineering for me is very different. This is about people who now have a profession, like it's a skill set. It will use DevOps principles, but they are going to be creating platforms for people to consume, which is like the internal developer platforms. And Nick, maybe you can talk about what that is.
Yeah, sure. So the idea really of Kubernetes as we move forward, like the shape I see from all those events, all those conversations, is really abstract the Kubernetes complexity so that developers can adopt the platform, because developer adoption has always been the key topic for Kubernetes to be boring. Right, that's the goal. We want
they complain a lot too, right? Hey, I'm not trying to defend Kubernetes too much here because it does have quite a high barrier for entry, but like developers generally, if you think about it from a business perspective as well, you want developers to be focused on your core business. You don't want them to have to be suddenly becoming Kubernetes experts. You want them to be building the apps that matter for you. And I think that's what this movement is all about. DevOps just kind of, I don't know, DevOps is a big part of it, but it's definitely not
horizontal. DevOps is like, as I said, is a philosophy every team, every department should adhere to, right? SRE is a job title. I think we were discussing the other day, SRE or platform engineer is just the new sysadmin or system engineer that we had in the past, right?
20 years.
Yep. 20 years ago, we were all like sysadmins, right? Exactly. Or Linux sysadmin or Wintel sysadmin, or it's just an extension of that, because now it's like the way the OSI model has changed for data center, right?
Well, the skill set
is the platform now, right?
The core skill set is the same, right? It's like you need to know networking, you need to know about abstractions, you need to know about Kubernetes, you need to know about storage, you need to know about a whole bunch of stuff to understand, the lower layer of the infrastructure. What's different now, I think, with platform engineers is you have to look at the next layer up and say, it's not now that I give you a server or I give you a cluster.
Yeah, exactly.
Now it's that, oh, no, I give you an abstraction layer for you to get access to this stuff. Kind of similar to, like, is it Cloud Foundry in AWS? and what's the Spotify one?
Oh, Backstage.
Yeah, Backstage. Exactly like that. So if you're working with Backstage, I can imagine that you still need to know all the stuff down the bottom, but you
Yeah.
also need to be very aware about all the stuff, all the way
Yeah.
people are going to consume your
Yeah.
IDP.
Yeah, and also just to finish on this, just to link back to what we were saying before, it's bidirectional, right? So developers, like, they need to incorporate some of the library and like distributed tracing into their code, and then things need to be bubbled up into Kubernetes through controllers and operators. So because we have this thin layer of integration, this is the job of the SRE to educate and to maintain all this, to have all these operations done on the platform. Because now, yeah, as I was saying, it's not delivering a server, because the server, the OS, is now Kubernetes. So you need, the same way you need to know Linux and Windows back in the days. Now you need to know the above layer, right? So the OS, Linux, which you want as small as possible, but the real OS becomes Kubernetes, and Kubernetes itself becomes a library for your developers.
Mm-hmm.
That's exactly the idea.
Okay, so we're at the end now, and we're on to next steps. And Nick, I think you were going to do the outro.
Sure.
But we've got time for questions as well, if we can hustle this one.
Yeah, 50 minutes. We've got still some times. we said you've got 1 hour.
And how many questions do we have? I can see this ominous-looking chat bubble with like a big number next to it.
So yeah, just to finish up. So whatever we said today, again, it's will be available on demand through the platform, the BrightTalk platform. If you want to learn more on some of the topics, I know, Anton, you also wrote a lot of blogs. I wrote a lot of blogs that are accessible through our website. You can also join our community Slack, which is especially helpful if you're interested into Kairos or local AI, all this kind of project that we are building. Take a look at them on GitHub too. Yeah, that's pretty much it. And I think, Anton, you were quite happy to drive and to have anyone have a tour personally with you about what we do about our
Spectro. Yeah, absolutely. I never get bored of. I enjoy doing one-on-ones with people. If you're interested in MAS, for example, Metal as a Service, or you're interested in Palette, which is our product, which does Edge, does enterprise, and also integrates with a lot of CNCS stuff, I'd love to show you around.
Yeah, cool. Okay, I see we have a couple of questions. Maybe we can start with the last one. So do you see cross-plane adoption to increase going forward to provision Kubernetes infrastructure, or will Terraform continue to dominate? Or we didn't go into the Terraform.
We had it in the notes. We had some stuff in the notes. I mean, well, let's talk about Terraform first, because obviously there's two projects out there. The other one, Tofu, which I see is making a lot of inroads. So there's both Terraform and Tofu there, which was a fork of Terraform. I don't think it's going to go anywhere, honestly, and I think Terraform being run from GitOps is a thing, and we're seeing a lot of that. But I think crossplane is also, super interesting. Now, the difference is one requires a cluster, right? And
yeah, sure. So
I run it from a cluster.
Yeah. So if you ask me, my personal opinion would be that even as someone who deploy environment and infra every day, Kubernetes cluster, I've stopped using Terraform 1.5 years ago for cluster API and crossplane. Right? So for me, Terraform today, except if you're in AWS and you do a lot of stuff, you have a lot of existing things going on here. If you're going 100% Kubernetes, then obviously Terraform is not required at all. Crossplane, cluster API, all those projects can be run from a laptop. Yeah, you need a cluster, but there's Kind, there's Minikube, there's everything. And it's going to be a lot easier. If you know Kubernetes already, you don't need Terraform. This is my point. And I've been pitching since day one that Kubernetes came up. This and that's my advice, really use Kubernetes as your automation engine, because it's a easy way to abstract everything. And there's a Terraform operator. So at the beginning, like say 5 years ago, I was using the Terraform operator in Kubernetes so that I can create YAML configuration for my Terraform scripts. I was wrapping it up into a Terraform operator because I thought it was better. It's just a better way to maintain your state and not being, because let's face it,
I'm not an expert.
I even forget. This is what people do with Terraform anyway.
I'm not an expert with crossplane, but I have looked at it and it looks really, really nice. And I can definitely see the appeal for sure. So I think my prediction is, I'm going to put it in terms of predictions for next year. Terraform's not going anywhere. Tofu is coming as well. Crossplane is definitely, it looks awesome. I'm sure it's going to be growing like crazy. I think it can be used for more things than just infrastructure, right? You can create these XRDs for anything you like. And we were discussing earlier, Nick, you and I, that you could use Crossplane for consolidating all of these CRDs that are running around.
Yeah, definitely. A couple of other questions here, and we have a couple of 5 minutes. Okay, so Spectro Cloud, I know for the edge solution. How is your edge solution going to evolve with these predictions?
Yeah, that's good. So I think the biggest thing that we're going to be doing over and above what we already do for managing clusters at scale is we're going to be doubling down on that. So we think that edge definitely is about scale. It's about number of small clusters. So we're going to be making more and more investments into making it easier for you to manage those things at scale, rather than you needing to build some kind of more Terraform or more scripting of your own to drive our platform to do the operations that you need to do. So what I mean by that is we'll be bringing more and more of that into the product directly so that it doesn't need to be built.
That's clear. And last question, which events do you recommend to attend in 2024 in the cloud native space? So I guess I can take this one. KubeCon is one, but as I always say that, my preference now goes to the smaller local events. So wherever you're from, there's probably a KCD that's not too far from you. This year, there were a lot of KCD first in Austria, in Sweden. There's KCD in Norway. I think it's going to be the first as well in Oslo next month.
There's one in Stockholm.
Stockholm has, is it like a meetup, I guess, right?
There's container days.
There are chapters. So go to the CNCF page for like the local type Kubernetes community days. I'm sure you will find something, a chapter or a complete like a local one. But now all over Europe, there are a lot of them. There's KCD LA that's coming up in March, just before KubeCon. So if you're based in the US, in California, that may be a good event to attend to. But yeah, check out the CNCF page for KCD, and that's my preferred event. KubeCon, it's really, really big, but if you really want to have those local conversation, meet new people, KCD is probably the easiest way to get into the community.
Hang out with Nick and have typing competitions.
Yeah, true. Dude, you're like, what is your 150 word per minute?
150. Yeah.
Man, no, it's not possible. I'm struggling with 100, which is already fast.
That's what happens when I'm waiting.
You were a pro FPS player, right? So
yeah, Counter-Strike.
Used to go fast.
Do we have any more questions?
No, that was it for today.
Okay.
So I guess we can close it now. We've been. Do we have another one? No, that's it. Okay. So thank you everyone for joining today. We had a lot of fun, and hopefully it was also fun for you, and you learned one thing or two. Any final word?
Let's hope so, right, Nick? And also, find us on LinkedIn and add us, or on X, Twitter, whatever it's called these days. We love talking to you guys, so we'll be hanging out for that.
All right, guys. Thank you very much. Enjoy Christmas. Bye-bye.
Merry Christmas.